All right. Hey guys. Obviously not here today, so figured I would make a lesson video for you. We're starting up a new chapter. This chapter is all about, well, a lot of the stuff that we've been doing has been about triangles. But specifically, we're going to be looking at right triangles, so that's any triangle that has 90 degrees. Today's notes start out with something that's hopefully a little bit of a recap for you, and that's going to be Pythagorean theorem. That just happens anytime we've got a 90 degree triangle and that we know all the sides. We can go through, as long as we know two of the sides, we can find the third side. One of the words that we use in vocab is a Pythagorean triple, and that's basically, it's a set of whole numbers that form a right triangle. You guys are going to get a lot of decimals when you do Pythagorean theorem. And this is specifically referencing a set of whole numbers. The best example of a Pythagorean triple is a 3, 4, 5 triangle. And just what that means is one of your sides is 3, one of your sides is 4, and then one of your sides is 5. So this is an example of a Pythagorean triple. Just a real quick heads up on vocab, I guess, just in regards to triangles and right triangles and things like that. C has to be your hypotenuse. So I'm going to write it as HYP. This has to be your hypotenuse. We know that C is always the longest side, but it's also the side that's across from the right angle. So when you're solving out triangles that have to do with Pythag, you have to be really cautious. A and B don't really matter. A and B are just what we call legs, and those can be interchangeable. It doesn't matter which side is what. However, the hypotenuse is super important because that does belong with C, and C is in a separate part of the equation. You can see that in a right triangle, the square of the length of the hypotenuse is equal to the sum of the squares of the lengths of the legs. Now, we won't really ever define Pythag like this. We'll almost always say Pythag is just a squared plus b squared equals c squared. But I do want you guys to recognize this. The square of the length of the hypotenuse. So basically, take your hypotenuse squared, and that's equal to the sum, that's addition, to the squares of the legs. So leg squared plus leg squared. And sometimes the reason I like to write it like this is that it shows you this C term, this hypotenuse, the C term is, well, a hypotenuse. The hypotenuse has to be on its own side of the equation, and then it's just leg squared plus leg squared. We're going to go through and do just a few examples. Here are some of the common Pythag triples. What I want you to recognize is that these are multiples as well, meaning that 3, 4, 5, if you multiply it times 2, you get 6, 8, 10. If you multiply it by 3, you get 9, 12, 15. So this is just referencing you can multiply them all out. So we are really looking for 3, 4, 5s, 5, 12, 13s. The other ones are definitely Pythag triples, obviously, because they're three whole numbers that create a right triangle. But the ones that I boxed, the 3, 4, 5, and the 5, 12, 13, and then like the 6, 8, like these are probably the most popular ones that you run into. Beyond that, we don't really see like triangles that big. But kind of recognize these because when you recognize them, it means you have less work. If you have a 3 and a 5 and you know it's a right triangle, it's guaranteed that the other side has to be 4. Converse of the Pythag is just flipped. We said previously, if it's a right triangle, then Pythag is true. And now we're saying, if Pythag is true, then it's a right triangle. We've seen these converses a bunch. We're going to skip this section of the Pythag inequalities, and we're going to go just straight to the notes, straight to the examples. So if you guys want to turn the page, we're on 246 now. And we're just going to do a couple practice problems. It says, find the value of x, and then tell whether the side lengths form a Pythagorean triple. So to do this, what I need to recognize is this is my C term. This is across. So x is by itself. So let's just make sure that we have 81 squared, 108 squared on the same side of the equation, and then x is off by itself. If I go to my calculator, I can type in 81 squared plus 108 squared, and I get some pretty big number, 18,225. So this is just simplifying the equation. We get to this point and recognize we have to get rid of the square. We've got a square sitting here, so we undo it with the square root. That's what the opposite of squaring is square rooting. So now we go back to our calculator. And if I type that in, square root of 18,225, I get a decent number. And my number is 135. That means this up here is 135. And the question does say, tell whether the side lengths form a Pythagorean triple. Well, we've got 81, we've got 108, and now we've got 135. So yeah, absolutely, this is a Pythag triple. Because it's all whole numbers, there's no decimals. If I look at a question like number 3, it's actually very, very similar. We have both legs. You'll recognize that 15 is a leg and 20 is a leg. And then x is my hypotenuse. That's going to be my C term. So once again, I can do 15 squared, 20 squared, x squared. So these all solve out in a very similar way. I actually get 625. And when I square root that, once again, I get a positive number, which is awesome. And not just positive, really, I got a whole number. So therefore, I know I've got another Pythag triple. I skipped number 2 on purpose just because I want you guys to recognize that number 2 is a little bit different. The reason number 2 is different is that I have 8, and 8 is sitting across from the hypotenuse. It is not uncommon for me. In fact, I almost guarantee, without me saying this, I probably would have had a lot of students that set the problem up like this. And this is where we can get ourselves into trouble. 8 is a C term. 8 is a hypotenuse, so it has to be by itself. So this equation as written is incorrect. What we're going to have to do is we're going to need to set up x squared and 4 squared and set that equal to 8 squared. 8 is a hypotenuse, so it has to be on its own side of the equation. Now what I can do here is I can still solve this out like a regular problem. But let's just be quick and cautious. Please do not do this and say that 8 squared minus 4 squared is 4 squared. You cannot take these bases. You can't take 8 minus 4. We need to take 8 squared minus 4 squared, which is actually 64 minus 16. Okay, so that's really what we're doing here. Not 8 minus 4 and then square that. We're taking 64 minus 4 squared, and that gives me 48. And when I go to square root this 48, I end up with a decimal. Now, we could break this down like we used to do with radicals. For now, I think I'm just going to allow you guys to do decimals. The great thing about Pythag is we can find lengths. Say that I was outside working on my house and I needed a length of something. I'm not going to break it into square root form. I'm not going to break it and say, oh, that's 3 root 2 inches. No, if I'm trying to find the hypotenuse, I'm most likely going to give a decimal form. I will have to convert that into a fraction if I'm using like our American units, because all of our inches are 3/8 inches or 5/32 or something like that. But the decimals are going to help us out a lot more than the square roots will. So I'm okay with a decimal approximation. Obviously, looking at this, we have 8, we have 4, and then we have 6.92. This is clearly not a Pythag triple. It's not a whole number. It's a decimal. All right, there are 3 more examples. I feel like I'm hoping that we're doing okay with some of these, just because we've seen it before. The one thing to mention again, check out number 4, 6 and 10. These are both legs. Number 6, 48 and 90. These are both legs. They're going to be set up pretty standard with a squared, b squared, c squared. However, watch out for number 5 because you've got a leg and a leg here. So you have x squared. And then 77 is what's by itself. So don't always assume that the x is the thing that's supposed to be by itself. Okay, we're going to go back up because I told you that we needed to check in on another question. Here, 9.3, we're back on page 245. It says, if the hypotenuse, we know that's because it's C, is smaller than leg plus leg. If the hypotenuse is smaller than the sum of the legs, it must be acute. If the hypotenuse is bigger than the sum of the legs, then it must be obtuse. Remember, now we do have to square these out, so I probably should be careful. So we're going to take leg squared plus leg squared, and we're going to take hypotenuse squared, and we're going to compare these numbers. Again, if the hypotenuse is bigger, it's obtuse. I'm going to say that a couple times. We know that the hypotenuse is always the biggest side. So what I'm going to do is I'm going to set the biggest side off by itself. We're going to take 90 squared plus 216 squared. This gives me 54,756. Big number. And I'm going to take 234 squared. This gives me 54,756. What does this mean? I took my legs squared, I took my hypotenuse squared, and they end up equaling each other? Well, if a squared plus b squared equals c squared, we know that it has to be a right triangle. So this is just a right triangle. How did I know? Because my a squared plus my b squared equals my c squared, because my legs equaled my hypotenuse. Now, if I were to try it on something like number 1 here, or number 9, 1 squared plus 1 squared, and then I'm going to compare that to root 3 squared. Well, 1 squared plus 1 squared is just 1. Oh, actually, that's not, no, it's not. 1 squared plus 1 squared was 1 plus 1 equals 2. And then if I type in root 3 squared, the square actually cancels out with the root, giving me 3. So if I compare this, I'm going to write in this inequality. Notice how I did that. I didn't know what this inequality was going to be, but then I recognized that 3 is bigger than 2. And otherwise, no, my hypotenuse is bigger than my legs. And then when my hypotenuse is bigger, it must be obtuse. That's something you guys are just going to have to memorize. Just like up here, we see if my hypotenuse is bigger, then it must be obtuse. Let me just give you one more example. Let's say we had a 3, 4, and 6 maybe. A 3, 4, 6 triangle. Is this going to be right, acute, or obtuse? Try it. What you guys will do is you'll take 3 squared and 4 squared. These are known as my legs. You're going to take 6 squared. 3 squared plus 4 squared is 25. 6 squared is 36. So we ended up figuring out that my hypotenuse was bigger than my legs. So again, it's obtuse. You guys will have a few examples in your notes where you might get something acute. All right, guys, well, hey, why don't you go ahead and get out that worksheet. We'll pass that worksheet out, and you guys can work on that. Do your best kind of going through those questions, and we'll make sure to check in when I get back.